Hi friends, today we will be discussing about the concept of light. Actually light comes under optics. So there are two branches for optics. One is known as the ray optics and the other one you call it the physical optics. Today I will be discussing about the physical optics. So in case of ray optics, we will be considering the various kind of glasses, mirrors, lenses and all. Now today I will not be talking about any glasses or lenses. Today I will be talking about the physical optics. Now what do you mean by physical optics? Now physical optics talks about the various characteristics of light. Okay, now if I take a plane surface and if I incident a light on this surface, now say this is a light ray, then what happens? Then you find that this light ray again gets reflected. Okay, so reflection is a property of light. Of course, reflection is a property of many things. Most of the waves, they get reflected. Now light comes under the bigger concept of waves. Now we know that waves are actually divided into two types. One is the longitudinal wave, the other one is the transverse waves. Now light is a transverse wave. Okay, light is a transverse wave, and most of the waves, they get reflected when they bounce on a surface, a denser medium. Okay, now what actually is light? What do you mean by light? Actually, a light is an electromagnetic wave. So it has two components. One is the electrical component, the other one is the magnetic component. It's actually a sinusoidal wave. It has both electrical components as well as magnetic components. If I now I'll try to draw the light wave. Now here I have the electrical component, I'll call it E, electrical component, and perpendicular to this I'll have another component known as B. So this is the electrical component. I'll use different colors for E. Now this is E, okay, and perpendicular to this I have B. So both this E and B, they are perpendicular to each other. Here E and B, they are perpendicular to each other. So perpendicular to each other. Okay, so what is light? Light is actually an electromagnetic wave. Okay, now this electromagnetic wave has two components. One is the electrical component, the other one is the magnetic component. Now how does these two components lie? Both the components are perpendicular to each other. Now from where does the light come? Now what is the direction of the light itself? The direction of the light is perpendicular to both E and B. Okay, now this is the x-axis. The vibrations of E are along the x-axis, and if I say this is the z-axis, this is the y-axis, then this is the component of magnetic field. So x has been taken by E, y has been taken by B. So the direction of the light would be z. This is z. So this is the direction in which light moves. So remember, light always moves in a direction perpendicular to both electrical field and magnetic field. Of course, when we talk about light, the first thing that we talk about is the electromagnetic spectrum. Now I want to discuss a bit about electromagnetic spectrum, and from there on I'll try to discuss the properties of such as reflection, refraction, diffraction, interference and polarization. Okay, now the electromagnetic spectrum starts from, now if I say that this is an electromagnetic spectrum, then the first ray that we observe is the gamma ray, okay, and the last things that we would be observing are the radio waves. So these are the radio waves. So this actually what you call it as a electromagnetic spectrum. So this is a spectrum. A spectrum is simply a collection of various lines. Okay, now let us discuss the various parts of the electromagnetic spectrum. Now I have said that the electromagnetic spectrum starts at the gamma rays. Now these are highly energetic light. This is a highly energetic light. Now this gamma ray actually comes from a nucleus. Now a nucleus spits out this gamma ray, and this gamma ray is responsible for various decays. Okay, now this gamma ray is so powerful that it can break an atom or a molecule. If I have a simple molecule, then I could break that molecule using this gamma ray. Even this has the capacity to break atoms itself, that is, it can remove the electrons from the atoms itself. Okay, so these are highly energetic rays, and these are also very dangerous to the human beings. Okay, when these rays fall on our skin, they have the capacity to simply penetrate through the body itself. Okay, now we know that X-rays could be used to take the inner photographs. X-ray could be used to take the photograph of my skeleton. Now gamma rays, they don't take the photograph of your skeleton, they simply penetrate through the body. And when these gamma rays, they start to penetrate through the body, they will not simply penetrate, but they will attack the cells in your body, and the cell would die, because these gamma rays are highly energetic rays. Okay, now after X-rays you have this. Now after gamma rays you have X-rays. Now we all know what X-rays are used for. Of course, they are used to take the photographs of the inner parts of your body. If I have a fracture, then how can I detect whether I have a fracture or not? I could use an X-ray. Now X-ray gives you a photograph of your inner parts. Now we know that an ordinary light gives the photograph of your outer skin, but if I want to take the photograph of your inner skin, then I could use X-rays. These are also highly energetic rays. Actually, the gamma ray wavelength is around 1 angstrom to 10 angstroms, and X-ray wavelength is over 10 angstroms to 100 angstroms. So these are highly energetic rays. Okay, so here angstrom is the unit for wavelength. Okay, now we have seen what a wavelength is and what are angstroms is in the concept of waves. Okay, so I will not be discussing these things here, though we have discussed already in case of waves. So we have alpha, we have the gamma rays, we have X-rays, and after that we get the ultraviolet rays. So these ultraviolet rays are also very dangerous for our skin. So therefore the outer atmosphere has a layer called as the ozone layer that absorbs these ultraviolet rays, so that these rays do not come into the lower atmosphere. Okay, so ultraviolet rays. Next comes the visible light. Next you have the visible light. Now this is the part of the spectrum that we observe. This is the part of the spectrum that we can see using our naked eyes. We cannot see gamma rays, we cannot see X-rays, we cannot even see UV rays. Okay, now after visible light you have IR, that means infrared rays, and thereupon we have these microwaves. Then you have the radio waves. Now radio waves have a larger bandwidth. Their wavelength is their range of wavelengths is very much. Okay, so the visible light is what we observe. Now the visible spectrum, now this is a complete spectrum. It starts from 1 angstrom. Now I have said that the wavelength of the gamma rays is 1 angstrom, and what is the wavelength of the radio waves? It is of the order of meters. Yes, it is of the order of meters. So these are huge waves. So I could give a simple example here. Now this is a normal wave. Now this is the wavelength lambda. Now if I have a larger wave, could be something like this. So this is the lambda now. So lambda has increased many-fold. Okay, so this is the this is how you define this lambda. Now you find that the gamma rays have a very tiny wavelength, whereas the radio waves have huge wavelengths. They are of the order of radio waves. That is why when you look at the antennas, the receivers, you find that the receivers are very large. They are not very tiny. You can't use a gamma rays for communication. Okay, you can't use gamma rays for communication. You use radio waves and microwaves for communication, and the antenna size itself shows that the wavelength of these particular waves is very large. Now we know the use of gamma rays, we know the use of X-rays. Ultraviolet rays, we know they are not of much use, they are a strain to us. Visible light, we know, of course, visible light is what we use to look at the look at our surroundings. Now IR is another important thing. Now we know that we observe the visible light. Okay, we observe the visible light. Now when it comes to snakes and other animals, they cannot observe visible light. Now a snake cannot see colors. It has color blindness, so a snake cannot see colors. But what can it see? It can see IR. That is why a snake cannot see colors. It cannot distinguish colors. It does not know what red is and blue is. It does not know even the concept of colors. But what it knows is, it knows how to see, how to look at the IR. Now IR is very important for us. Now this IR is responsible for this climate change and all. Okay, this IR radiation is what is responsible for the problems that we are facing now, the climate change problems, the temperature rise, the temperature fall and all. This actually comes because of this IR radiation. Okay, now let us look at this IR radiation. Now I want to discuss about the infrared radiation, though it actually comes after the visible light. Okay, now the snakes, they actually can detect IR. Now when I am talking to you, I am actually producing heat. Each and every body whose temperature is greater than 0 Kelvin. Now when I say 0 Kelvin, it is minus 273 Kelvin. Okay, not Kelvin, minus 273 degrees centigrade. Okay, it is minus 273 degrees centigrade. So that is the least value that you can obtain. So when T is greater than 0 Kelvin, what happens? The body starts to radiate energy. It starts to radiate heat energy. Now, so I am actually producing now heat. You are actually producing heat. Any living being actually produces heat, and that heat comes in the form of the infrared radiation. So if I have infrared goggles, you might have watched in many films that people sometimes look like red and a part of them looks like blue. You might have seen the hotspot in case of cricket. Okay, now this hotspot is what? It's actually the heat energy generated when a ball hits the bat. So that is the heat energy, and that heat energy is actually captured by a camera. It's actually an infrared camera. It actually captures that heat, and that is how you have this hotspot in case of cricket. Okay, the similar thing happens when a snake observes a rat. It does not know whether the rat is black or white. What it knows is that that is a living being and that is producing some heat. So that is how a snake catches an animal, any prey. Okay, now this IR could be used to observe things in darkness. Now if you have this, now the modern soldier, he actually uses an IR goggles at night. Now when this what you call attack on Osama bin Laden took place, that took place at the night. It was over 1 o'clock that the attack took place. It was very dark there, but what these people did was they used the IR goggles. They took the IR goggles, and when they had these IR goggles, they could see everything. Now we cannot see under darkness. Our eyes are not suitable to see things at darkness. But if you use an IR, what happens is the IR heat energy can be captured by these lenses, and we could clearly see what is in front of us. Okay, so IR have their uses. IR could be used in many other forms. Now why is it a problem? Now IR also has some problem. Now I'll try to explain it in a simple way. This is Earth, and I've already said that any object whose temperature is greater than 0 Kelvin has to radiate. Now Earth also radiates heat energy. Earth also radiates heat energy. Now this heat energy is in the form of IR radiation. Now there is an atmosphere around the Earth. There is an atmosphere around the Earth. Now this atmosphere has every other gas. It has nitrogen, it has oxygen, it has argon, it has CO2, it has everything. It has ozone. Most of the gases are present in the atmosphere. Now if somehow this CO2 concentration is increased, if somehow the concentration of the CO2 increases, then what will happen? Then you find that the CO2 has the capacity to absorb IR. Now CO2 absorbs IR, and what it does is it again re-emits. It absorbs and it also re-emits. So what happens? It is absorbing IR and it is again re-emitting. So you might be thinking, what's the big deal? If it is absorbing and it is also re-emitting, what's the problem? Now the Earth is emitting the IR radiation in this direction. Here I have a CO2 molecule. Now this CO2 molecule absorbs this IR radiation, it again re-radiates, and it re-radiates in the opposite direction. So therefore what is happening here? The earth is becoming like a pressure cooker. The earth is becoming like a pressure cooker where the radiation is again back radiated. Now the radiation has to move into the outer atmosphere. It has to go to space, but it is not going to space, it is again getting re-radiated, and that is why the temperature is increasing drastically. So earth is becoming like a pressure cooker. The pressure within the IR pressure within the earth's atmosphere is increasing very much, and because of this increase you have the temperature rise. This is what we call it as the climate change. Now CO2 is a greenhouse gas. Now methane is a greenhouse gas, and there are many other gases that does these things. They actually absorb the IR radiation and they are actually re-emitting the IR radiation, not in the direction of the space but in the direction of the earth. So that is how the temperature increases. Okay, so IR radiation has got its own advantages and also its own disadvantages. So this is about IR. Now microwaves. Of course, you might have all seen the micro ovens. Now the micro ovens, they use microwaves to heat up any substance. Now any substance means I can't put what you call any glasses or anything like that. What I can do is I could use any substance that has got some vapor, that has got some water. That is why in precautions people say that you have to use a material that has got some vapor in it, that has got some water in it. So when I put something in a micro oven, I have to make sure that it has got some vapor in it, has got some water in it. So microwaves could be used like that. Microwaves could also be used in case of radars. Now you know what a radar is. A radar is actually a radio. So what do you mean by a radar? A radar is actually a radio detecting and navigation and ranging device. So what does a radar do? It detects objects. It is also used for ranging. Okay, so a radar does both the detecting job, it also does the ranging job. Now what do you mean by ranging? It shows you how far the object is, and it also detects what kind of object that is. So that is what a radar is. Now so these are simple applications of the microwaves. Now radio waves, you all know what radio waves are used for. Of course communication itself depends upon the radio waves. Now when I say communication, I am talking about the normal radio. I am not talking about the satellite communication and all that. Okay, so we'll discuss these things when we talk about the communication. So radio waves, we all know what radio waves are used for. In a radio these waves are being used. So the bottom line is light is an electromagnetic wave. It has two components, electrical component and magnetic component, and the direction of the wave is perpendicular to both the electrical component and magnetic component. Okay, now when we are talking about the electromagnetic spectrum starts from the gamma rays, it ends at the radio waves. Okay, so it starts from 1 angstrom and it ranges up to a few meters. So this is what I wanted to talk about. This is an introduction itself. Now let us look at the various properties of light. There are various properties of light. Now